Um, so welcome back. It's a little bit of an unprecedented return to school, but I hope you guys are all doing well and safe with your families wherever you are. So I'm going to get straight into the lesson and in hopes to not make this video too long. But we are starting the new unit. It's called Advanced Trig. Don't get too freaked out by the advanced. All that means is that we're working with trigonometry beyond grade 10. So what we did in the last unit was grade 10 trigonometry, and what we're doing in this unit is grade 11 trig. So just building off of stuff that we saw before. So we're going to be looking at today special angles, and there's quite a few special angles, but most of them stem from the 30, 45, and 60 degrees, and then the other ones are building off of these main ones. So 30 degrees, 45, 60 degrees. And what we're going to be looking at is how do I find the exact value of the sine, cosine, or tangent of these angles. In order to be the most precise that we can be, we always want to try to give, if we can, the exact value, and that's what we're going to be looking at today is how do I figure out the exact value of these. Okay, so we're going to start by deriving where the special triangles come from. So if we look at the first example on the left, so it's going to be called our 45, 45, 90 degree triangle. And where that comes from is from a square. So imagine that we have a square, you have that picture on the left-hand side, and all of its side lengths are side lengths of 1 unit. If we take this square and we split it down the middle, well then we end up with 2 right-angled triangles that are created, right? We have one right-angled triangle here, and we have a second right-angled triangle here. So I'm just gonna focus on the bottom left one, it doesn't really matter. But if I look at this right-angled triangle, it still has side lengths that are equal to 1 and 1. And then I can use Pythagoras to figure out, well, what's the length of the hypotenuse? So let's say that I'm going to label the hypotenuse with h. Then I know that 1 squared plus 1 squared is equal to the hypotenuse squared, so h squared. All right, so we get that 2 is equal to h squared, or h is equal to the square root of 2. And I'm not going to worry about putting in the plus or minus because I know that this represents a side length, so it's always going to be positive. The hypotenuse has to be positive, greater than 0. So there's your first special triangle that is created. So it's a triangle with side lengths of 1, 1, and root 2. So now if we talk about the angles that are going to be created, well, we already know that this one here is 90 degrees. And you have 2 ways that you can figure out the other 2 angles. You might be able to realize, oh, well, we've created an isosceles triangles, right? Because there's 2 side lengths that are the same, so both 1 and 1. So these 2 sides are going to be the 180, these 2 angles are going to be 180 minus 90, which leaves us with 90 degrees left over, but then we're going to take that 90 and divide it by 2. So that's why each angle up here is 45 degrees. All right, the other way you can think about that is that if you took those angles and we split them down the middle, well, you're splitting what was a 90-degree angle into 2, so you have 2 45 degrees. So there's our first special triangle, and this we're going to end up redrawing it quite a few times, often, so you're going to want to have that memorized or be comfortable recreating it so that you can use it when we go on and solve for special angles or special ratios. Okay, so now if I look over on my left hand or my right hand side, I'm going to try to zoom in a little bit. So now we're looking at a 30, 60, 90 degree triangle. Just going to highlight that, so 30, 60, 90. And where this triangle comes from is that we're going to start with an equilateral triangle, and it's a little bit arbitrary, but it's so that it ends up working out nicely. I'm going to give each side length a side length of 2. So it's an equilateral triangle that originally had side lengths of 2. And hopefully you're pretty comfortable with knowing that all of the angles within my equilateral triangle are 60 degrees. Right? So each one are 60, and this one up here, the whole thing was 60 degrees as well. And then we're going to take this triangle and we're going to split it down the middle. So by doing that, again, I create 2 triangles, and I'm going to focus on the right-hand side. And by splitting it down the middle, I take this side length and it gets changed into half of what it was, right? It's going to end up becoming 1. This side length stays the same. And then I can use, again, Pythagoras to figure out my missing side length. So I'm going to have that 2 squared is 4, and then I subtract the 1 squared, and 1 squared is 1, so I get 3. So therefore, a is equal to the square root of 3. And similar to before, I'm going to put in that it's a positive root 3. All right, I'm not worrying about the negative value. So here is my root 3. Okay, now let's go through and we'll talk about the angle. So we have a 90-degree angle that gets created when I split my original equilateral triangle down the middle. So that's one angle. This is going to end up being the same thing, right? It didn't change, right? It's still 60 degrees. And then you can either think of it, well, I have 180 minus 90 minus 60, which leaves me with 30 degrees, or we also took that 60 and we split it down the middle, which also gives me 30 degrees. Right, so there are your two special triangles that we are going to, like I mentioned before, get used to redrawing often so that we can use them. So if we look down here, these two special triangles are going to help us figure out, well, what does sine of theta when theta is 30, 45, or 60 degrees equal to? Same for cos and same for tan. So I'm just going to redraw the two triangles, or you already have them redrawn, but I'm just going to fill them in. So here we have a side length of 1, 1, and then this was root 2, and this is our 45 degree triangle. And then my second one, it's oriented differently. Don't worry too much about that, but just maybe be aware that it is oriented differently. So I'm going to put that my bigger angle is the 60-degree angle and my smaller angle is the 30-degree angle. This was the same as my original side length at 2. This was the side that got split in half, and then this is the root 3. So again, don't get too bogged down on the fact that it's been reoriented. It doesn't really matter. I end up drawing them always like this just out of consistency. And then maybe that would be helpful so that you draw them always the same way so that you're not getting confused as to where the angles go as long as you draw them always the same. All right, so now let's go through and we'll fill in this table. So let's figure out what is the exact value of sine of theta when theta is 30 degrees. So we'll start with looking at 30 degrees. And that means that I'm working off of this triangle here because this is the triangle that has the 30-degree angle in it. So if I'm looking at, well, what's sine of 30 degrees? So go back to our basics that sine is opposite over hypotenuse. So there's our SOHCAHTOA. So I'm going to have that the opposite is 1 over the hypotenuse, which is 2. So this is going to have a value of 1 over 2. Okay, if I keep going, now let's look at the cos value of this angle. So cos is now adjacent over hypotenuse, so I have that the adjacent is root 3, and I'm looking at the adjacent to 30 degrees, and the hypotenuse is still 2. So now I have that that exact value is going to be root 3 over 2. Tan of theta, we have opposite over adjacent, so that is going to give me that my opposite side is 1, my adjacent side is root 3, and often we do not like to have radicals in the denominator. It's not proper form to have them in the denominator, so we're going to rationalize this by multiplying it by root 3 over root 3. So 1 times root 3 gives me root 3, and then root 3 times root 3 is equal to 3. I think if I remember properly, your textbook doesn't rationalize the denominator, so just be aware if you're looking for solutions that sometimes it doesn't. I will expect that you do rationalize it, so please get into the habit of doing that. Okay, so now we're going to look at our 45-degree angle, and we're going to do the same thing. So you'll notice probably pretty quickly that, well, I have two options to choose from when I look at 45 degrees. I can either look at this 45 degrees or this one, and it doesn't matter because you're going to end up with the same answer either way. So let's say that I just work off of the top angle. So sine, again, is opposite over hypotenuse, so we'll have 1 over root 2. The opposite side is 1, and the hypotenuse is root 2. Again, let's rationalize that denominator, so times root 2 over root 2, and we'll get that your final answer is root 2 over 2 once it's rationalized. Cos will do the same thing, and you end up actually with the same thing because the adjacent side and the opposite sides are actually both 1 and 1. So that's why it didn't matter which 45-degree angle I chose. So 1 over root 2, multiply it by root 2 over root 2, and we'll get the same answer, root 2 over positive 2. Okay, and then last but not least, tan opposite over adjacent, we get 1 over 1, which just equals 1. All right, next angle, 60 degrees. So that's this one down here. So sine, we're going to have opposite over hypotenuse, so that's going to give us root 3 over 2. Cos is going to be adjacent, so now that's going to be 1 over 2, right? Because our adjacent side to 60 degrees is now 1. And then tan is going to be opposite over adjacent, so we'll get root 3 over 1 which is just root 3. And that's what we use our special triangles to help us with. We're going to work with getting the approximate value. So if you had tried to do this in your calculator, I don't think this is going to work, but what you would want to do is make sure that you're in, no, sorry, it's not going to work. Make sure that in your calculator you're in degrees, and then if you do, say, for example, tan of 60 degrees, it's going to give you the approximate value. It's going to give it to you listed out in decimals. So when you see decimals, if the decimal goes on forever, it means that that's not the exact value. You're still approximating it. Even if you put in all the digits that your calculator presented to you, it's still not the exact value because it goes on technically forever. We're only seeing what our calculator can store or what our calculator can present. So one way that you can always double check it is go down, make sure I'm just double checking my calculators in degrees. Okay, so I can quit. And if I go on and say, for example, well, tan of 60 degrees, my calculator is going to tell me that is approximately 1.73, right? It goes on for more, so it's about 1.73. This is the approximate answer. But double check, does the square root of 3 equal the same thing? Yeah, it does. It also equals 1.73. So it equals to exactly root 3, which is the exact value. Okay, so let's put this into practice, and we'll actually go and do some examples. So if we look at the first one, it says find the missing side length, expressing your answers as an exact value. So we'll look at what does this value here equal to, so x. So you have given to you a 60-degree angle, and you're going to probably get into the habit of this, of recognizing, oh, okay, well, I'm going to be working with 60 degrees, 30 degrees, and 45 degrees. So recognize that those are going to repeat themselves pretty often. So if I'm looking at my 60-degree triangle, that means that I'm probably, or not that I'm probably, that I most certainly am using this triangle. I'm just going to copy it. I know you can't, but you can pause the video and redraw it. So I'm going to copy this, and I'm just going to paste it down here so that I have it to use. Okay, so I'm 60 degrees. So if we look at what we're given to that 60 degrees, you have that this is the adjacent side to 60 degrees, and this is the hypotenuse to 60 degrees. Well, if I have the adjacent and the hypotenuse, go back to what we learned last unit, that means I'm going to be using, so TOA, I'm using cosine. So I'm going to set that in, or present that up, that I have, and I'll write this on the right, cos of 60 degrees is equal to my adjacent side, which is x, divided, and we should actually have a 90 degree in there, that's not written, divided by 4 root 3. Now, because we want the exact value, I'm not just going to take my calculator, punch cos of 60 in, and get what my calculator spits out, which is the approximate value. I'm going to actually go to my special triangle and see, oh, what does cos of 60 equal to? So if I look at my special triangle, cos adjacent over hypotenuse, cos of 60 is exactly 1 over 2. It's exactly my adjacent side of my hypotenuse. So I can replace this cos of 60 with it equaling 1/2. Right, and that's probably, or that should be consistent with our table. If we go back to our table, cos of 60, yeah, we said that it equaled to 1/2. We did that before. Okay, now we're left to do is cross multiply, so, or to solve for x, so you're going to have 4 root 3 equals 2x, or x equals 2 root 3 when I divide both sides by 2. So there's my exact value for x. All right, let's move on to the next one. So this one a little bit tricky to see what the y represents, but I think it represents, or it should represent, let's clean this up. Should represent this side here. So this is going to be my y. All right, so we have 2 triangles given to us, so I'm going to work off of the one that's I have more information, the one that I actually am given a side length. So I'm going to start with this top triangle up here. All right, so that's going to be the one I start with. So maybe put a little 1 that's we're going to work with. Okay, so this has a 30 degrees in it. So when I look at this 30 degrees, this is the opposite side to 30 degrees, and this is the hypotenuse to 30 degrees. So if I'm working with opposite and hypotenuse, I'm going to be setting up my sine ratio. So I'll say that sine of the 30 degrees is equal to the opposite side, which is 5 root 2 divided by the hypotenuse, which is y. Now, go back to your special triangle, which you have already written on the left, or hopefully you have on the left. We're looking at sine of 30 degrees. Okay, that means that I have my opposite side and my hypotenuse, which are going to repeat to be 1 over 2 again. So this is going to equal to 1 over 2 is equal to 5 root 2 divided by y. Again, cross multiply, so we get 5 is equal to 10 root 2. Remember that when you're working with radicals, we multiply coefficients with whole numbers, and the radical, we treat it like a variable, right? So you're not multiplying that 2 times the root 2. All right, so your final answer there, and your exact value would be 10 root 2. Okay, now last but not least, we do have to figure out this x value, so that's working off of this bottom triangle now. So looking here, and it's an isosceles triangle, so that's going to help us out a little bit. So we know that these two sides are the same, so therefore if you have a 90 degree in your triangle already, these are going to have to be 45 degrees. So x, to say maybe this 45 degrees I'll work off of, it doesn't matter, but let's say I'm using that one. X is adjacent to it, and the y, which is the only other side length that we know because we just solved for it, is the hypotenuse. So we're going to say that cos, this is our second triangle, of 45 degrees is equal to x divided by y, but we know that y is 10 root 2. Okay, so we can fill that in, and this is still cos of 45 degrees. Cos of 45, if you look at your special triangle, so now this is working with this special triangle here. So I'm going to copy that and paste it down here. Okay, and I'll just make it a little bit smaller. So this is the special triangle we're working off of. So cos of 45, let's look at that top angle there. You can't see this anymore. Oh, there we go. Cos of 45, you're going to have that it is adjacent over hypotenuse, so we're going to get 1 over root 2. You can rationalize your denominator right now, but it's probably going to work itself out when we cross multiply. So don't stress about it too much, because when I cross multiply, I'm left with root 2x equals 10 root 2, or x is equal to 10 when I divide both sides by root 2. Right? These are both going to cancel out. So your exact value for x is going to be 10. Okay, last but not least, let's take a look at these ones. So you're looking at evaluating this. So we don't have any diagrams, so we're just probably working with our triangles. You have your two special triangles there that you can refer back to. So tan of 30 degrees, looking at my special triangle, that is equal to exactly opposite over adjacent, so that exactly equals to 1 over root 3. And cos of 45, that is equal to exactly 1 over root 2, and I'm going to rationalize the denominators at the end. So I get that this is 1 over root 6 times, rationalize your denominator, root 6 over root 6, and we get that it is root 6 over positive 6. And that's it. You're done. There's your exact value. You can always double check your answer by putting it into your calculator and seeing, does the answer that my calculator spit out equal what the approximate value of root 6 over 6 equals. Okay, almost there. So sine of 60 degrees, I go back to my triangle, so my 60 degrees, I'm doing sine. Sine is equal to opposite over hypotenuse, so I get root 3 over 2. Tan of 45, I'm going to get that that's 1 over 1 divided by cos of 30 degrees. Cos of 30 degrees is going to be root 3 over 2 as well. So when we do this out, I have a fraction in the numerator and a fraction in the denominator, so I'm going to keep switch flip. My numerator becomes root 3 over 2, because when you multiply it by 1, it doesn't change. I'm going to now change this to a multiplication and take the reciprocal of the denominator, so times 2 divided by root 3. Beautiful, these cancel out or reduce out to be 1, right? Because this and this reduce to 1, and this reduce to 1. So you're left with 1 times 1, or just 1. And that's going to be it for today. So I've left you guys with some questions to try out on your own. The answers will be posted in our Google Drive. So in the completed note, you can go and double check if what you have is the correct answer. So it'll be filled in. And then your homework is just IXL practice that has been posted on Edsby. So I'll put further instructions on Edsby with how many questions I think you should be doing. And if this is something that seems a little bit foggy or that you realize you need an extra couple questions to help you out with, here's some extra practice as well with the answers on the right hand side. All right, good luck guys, and see you on Friday.